part, I'm going to talk about if you have modulus on both sides. Okay, so what you're going to do is to go and square both sides. Of course, number one, you can use a graphing calculator to find out your answers. Okay, but number two, if the question says I only want it to be algebraic way, or if you must put it in an exact form, then you have to know, okay, I have modulus on both sides. Modulus are all positive. To make everything 100% positive, I square both sides. When I square both sides, it can remove the modulus. Okay, so I'm going to just put modulus here, x minus 3, okay, and here, square, I'm going to have x squared less than 4, sorry, this is not 4, be careful of careless, this is 16 x squared minus 6x plus 9. Okay, so I'm going to move everything to the right side, 0. I'm going to get 15x squared because I'm open up and then minus the x squared, minus 96x, okay, plus 1, 9654, so 144. Okay, so if you cannot factorize this, okay, if we cannot factorize this, then the better way would be use the quadratic formula, minus b plus minus square root of b square minus 4ac over 2a. Okay, so I'm going to use my calculator, plus minus square root of 576 over 30. Okay, and actually this guy can be simplified to square root of 576 is actually 24. So I'm showing you that what if your square root cannot simplify? Then you got to leave it in insert form, and this is how to find the exact form in the inequalities. Okay, so this will be actually be 96 plus. Okay, so this is 4 or 12 over 5. Okay, so these are the roots. So don't forget, if I'm going to present it in this way, this will be x minus 4, 5x minus 12, and then I'm going to use my plus minus plus. 12 over 5 is 2.4, 12 over 5 is here, 4 is here, plus minus plus, I'm taking the positive part because greater than 0, x less than 12 over 5 or x greater than 4. Okay, now some other times you may encounter things involving something like this. Oh, modulus x minus 1 over x plus 2, okay, lesser than x. Okay, in this kind of question, of course you can use your GC. Okay, you can use your GC to go and work out this guy is y equals to x. You have to know that it's going to be this part. Okay, the other one I'm going to use yellow. Okay, I'm going to use yellow. Sorry. So when I key into the GC, how to find the absolute value? Use alpha y. Okay, go to the right under the function, you will see absolute value. So I'm going to use x plus 1 over x minus 2. Okay, and then the other part will be y equals to x, and then I graphed it out. Yeah, you will be able to see that, okay, because this is a modulus graph, and in your transformation, you learn that the modulus graph, you have to reflect the bottom to the top. Okay, you have to reflect the bottom to the top. So in this case, the graph will look like this. I'm going to use red. Okay, there's going to be this part over here. And then for this part by right, this will go down. This will go down here. Okay, but because it's reflected, right, you need to know, okay, I'm going to draw the reflected, and then it's up here. Okay, so the red one is y equals to x minus 1. Yeah, okay. Modulus of x minus 1 over x plus 2. If you don't know how to draw the modulus graph before, you need to go to transformation, okay, and see how to draw the modulus graph. Okay, and then this is y equals to x. So the question is asking, when is y equals to x greater than this? So I'm looking at the blue graph to be on top of the red graph, and it is at this critical point over here. Okay, and it is at this critical point over here. Now, how to find this point of intersection? So first, you must know that for the red graph, okay, it consists of two. Modulus x minus 1 over x plus 2, right? can be equals to x minus 1 over x plus 2 or negative of x minus 1 over x plus 2. Okay, so the better way is to go and look at your GC again. Okay, if I'm going to remove the absolute sign here, what is the graph going to be like? Okay, so I press graph. You realize that this was the original graph. Okay, so I think I key it wrongly because it's supposed to be x plus 2 and not x minus 2. Okay, x minus 1, the other way around. But it doesn't matter. Okay, it's what I'm going to talk about, x minus 1 over x plus 2. Okay, so x minus 1 over x plus 2 instead. Okay, I pressed graph. So this graph was originally this way. Okay, so this graph was originally this way. It does not intersect the positive guy. Can you see it doesn't intersect the positive guy at all? So in order to find the point of intersection, I need to know, am I using the positive guy or the negative guy? See, when I plot the positive guy, it does not intersect. So now I'm going to go over here. What if I plot the negative guy? The negative of, I want to plot y1. Okay, I want the negative of y1. So all I'm going to do is to go down here. I press negative, okay, of y1. Y1 would be under, can you see VAR bus? Okay, so you press this, the y variable, y function, y3. Okay, so I'm going to plot the negative of y1, not y3. Okay, as my black graph, I'm going to deselect the blue graph. Okay, I'm going to press graph. See, it cuts over here, right? And this is actually the critical point where the graph, where the y equals to x will cut here. Okay, so I have to equate negative x minus 1 over x plus 2 equals to x. So I'm going to say that, okay, the negative of x plus 1 over x plus 2 equals to x, and I'm going to cross multiply. Plus 2x, 0 equals to x squared plus 3x minus 1. And in order to find this, I have to use my quadratic formula. X equals to minus b plus minus square root b squared minus 4ac over 2a minus 3 plus minus square root 9 plus 4, and that's 13 over 2. So this point is called minus 3 plus square root 13 over 2. And that is how I'm going to say that, therefore, the inequality, for this inequality to exist, for this blue graph to be on top of the red graph, I'm going to say that x is greater than negative 3 plus square root 13 over 2. Okay, maybe quite a bit of concept, but remember to understand that when you have a modulus graph, it's always made out of the positive one and the negative one. So to find the point of intersection, it's important to know which is the graph, either the positive one or the negative one, that intercepts with the straight line that you want, and then use the quadratic formula to find the point of intersection.